actually, I've got T and P as well, 8 variables. But of course, I'm going to set 2 of them. Set 2 gets me to 6. Once I get 6, I'm 6 equations, and I got to decide what to do. So I'm going to write down equations that people call purity equations and recovery equations. So let's see what we're going to do. I'm going to take these equations over here, and I'm going to eliminate F as L plus B. And I'm going to first, and I'm going to eliminate yi by using that. So when I do all this, so my first move is to eliminate F and yi. When I do that, I think I know what I get. I get xi equals zi times, 1 plus v over L divided by 1 plus ki v over L. This is called a purity equation. It's called a purity equation because it's got x on the left-hand side. Purity equation. Now, maybe you can see how that algebra works in your head and write it down, which is what I've just done. Or maybe you need to go home and work it out. Either way is fine. Now, the second thing I'm going to do, eliminate F and xi. I'm going to get yi equals zi. And I'll get L over v plus 1, L over ki v plus 1. Also called a purity equation. Okay, so I get these 2 purity equations. Again, you got to go over here, substitute for F, L plus V, eliminate x now, is that what it says over there, as yi over k. Yeah, it says eliminate f and x, and you get something that looks like this. Then I guess I'll multiply the top equation by L over f, and I will get L xi over, I guess, f zi. Also going to bring the z over here. And when I multiply the top by f by L, I get L plus v, which is f divided by f, which goes away. So you can derive this equation remarkably easily. 1 plus KIV over L. And you can go do the same thing here. And this is called a recovery equation. And you can do the same thing here. Multiply this one by v, divide by f. When you multiply this by v, of course you get L plus v. Divide by f knocks that out. So this is remarkably easy as well. So v yi over f zi is equal to 1 over L over KIV plus 1. So I've got 2 equations I'll call recovery equations, and 2 equations I'll call purity equations. And maybe what I ought to do is just write them up here in the corner of the board so we can sit here and enjoy them.
Professor,
Yeah,
what is a Z again? Is that just like X and
feed
Y?
composition.
What is it?
Feed composition. Here, let me draw you the picture. What we're trying to do is we're trying to send in a feed whose composition is Zi. We're trying to take an overhead product whose composition is Yi and a bottom product whose composition is Xi. This is how Z, Xi, and Yi fit together. Now that's true for all I, and we've got L's and V's and F's and so forth floating around. A Q might be needed to make it happen. So anyway, we have decided that there's an equation called Xi equals Zi times, what does it say over there, 1 plus V over L over 1 plus KIV over L. And we have YI, oh, well, we might as well put the recovery equation right with it. XIL over ZIF is equal to, that's gone over here. So this is 1 over 1 plus KIV over L. And I got the corresponding equation for YI, which is ZI, and I think what you get when you do this is L over V, and I guess you get L over KIV plus 1. And then when you go to recovery, you must get something like YIV over ZIF, and that should be just this, 1 over L over KIV plus 1. Got these for you. I'm going to use them whenever I need them. And I'm going to try and devise methods of solving these things by reducing our problems to one equation and one unknown. That's the aim. So I got my basic equation sitting there. Rearranged a little. And I am working the case where I don't care about Q. I don't care about Q. So I'm going to set 2 variables, and none of them are going to be Q. If I want Q, I'll go get Q after the fact. So there's about 4 standard problems that, so we will take a look at maybe 4 ways of setting 2 variables. Now, one thing I'm never going to do when there's only one stage, I am never going to set a pure, yeah, shoot.
On the purity equation on the right side of the board, where you have y equals zi L over d, isn't there supposed to be a plus 1 on the numerator?
Tell me, there's 4 equations there. 1, 2, 3, 4. Which one are you talking about?
Third.
3?
Isn't it L over d?
Oh, I think I'm missing a plus 1. Is that your point?
Yep.
Yeah, good for you. You know, we ought to talk about mistakes. Let's talk about mistakes. What do you know about mistakes?
A lot. Everybody makes them.
Huh?
Everybody makes them.
Everybody makes them. In addition to everybody making them, when your genes copy themselves, they make them too. That's sort of bad news. So when your genes are busy copying themselves, they're going to make mistakes. Now, I don't make a lot of mistakes or we wouldn't be here, but they make mistakes. So let's have a theory of mistakes. I'm likely to make mistakes. I think your genes make mistakes about 1 time every 1,000,000 copies or something, some number like that. I probably make a mistake 1 time every time I write 1,000 symbols. So in the course of a day, there's probably 4 or 5 mistakes up there. These mistakes are mine until the period is over, at which point they become yours. That's the theory of mistakes. So it's a good idea to pick them up, or it's a good idea to go home and look. And if you're a rat and you go home and you find a mistake and you don't tell your buddies, yeah, I can understand that. Oh, I need to say something. We're not going to have class next Tuesday or Wednesday.
You said that.
Well, I said that to one class, but there are people in, yeah. What you're supposed to be doing Tuesday and Wednesday is going and getting a job. Yeah? Yeah. So, look, you don't want to go over there with a shitty looking resume. That's one thing. If you've had summer work, you want to make sure you've included a short paragraph on all your problems that you've worked on, what the problem was, what you did, and what happened. Don't tell them you saved the company $5 million. They won't believe that shit. But you can make a nice statement about what the problem was, what you did, what happened. They'll be impressed. And they'll be so impressed they won't even ask you what your GPA is. On the other hand, if you haven't had any summer work, you got a problem, they're going to ask you what your GPA is right off the bat. So, be prepared. There's something else I can add to that. Here's the thing. About 20 years ago, we would graduate students and the companies would come here and they would say things like, we don't want to know who's got a 3.5. We don't trust those guys. We want to know who's got a 2.8. We're going to hire those guys, which is what they did. And those guys turned out to be great. Trouble is, they come back to interview now, 20 years later. They're going to say, I want to see a 3.5. You're going to say, buddy, you didn't have a 3.5. Well, you're not going to say that. I know a lot of these guys, and they're great engineers. They can do a lot of stuff with their hands. They got a great sense of how the physical world fits together, and their companies are thrilled with them. But there were no 3.5s. Okay, here we are. 4 kinds of problems. Here's our first problem. Yeah.
Does that mean the quiz is also
What was
canceled?
Can't hear you.
Does that mean the Wednesday quiz is also canceled?
Absolutely. Oh, look. Okay. Of course it is. Get serious. Okay, first problem. Set T, set the recovery of some component J in the overhead. Find everybody else. Okay, that's our problem. Now, this problem you can solve straightforward from beginning to end for the following. We'll see why. So, a person says, what is recovery of J in the overhead? Well, it's Y, I, well, it's ZI. The recovery equation is this guy down here in the overhead. It's 1 plus, what does it say there? L over KJV plus 1. The recovery of any other component, recovery of I, is 1 over L over KIV plus 1. If I flip this upside down, I have 1 over the recovery of I, less this 1 equals, I guess, L over KIV. Equals, now what I'm going to do is I'm going to go KJ over KI, 1 over KJV, and I'm going to go KJ over KI, and this will be 1 over RJ minus 1. That's, yeah.
Are they two separate, or does
Are what two separate?
like the right board and the left board, the middle?
This is simply the definition of the recovery of J, and this is simply the definition of recovery of I. The only thing I've done is written KJ here and KI there.
Are you multiplying KJ over KI times L over KJV?
I didn't hear you, but I'll
KJ
tell you
over
what I
KJ.
did.
It's one term in the middle.
He's doing KJ
Okay.
over KJ.
So does
Yeah,
it keep
notice that
going?
the KJs cancel out
So those are
deliberately.
Yeah.
Yeah?
So it's one equation?
Okay? So, all I did was I took this, turned it upside down, when I had the 1 here, I brought it over and I got that, which I got that. Now I say I don't like that Ki, so I write Kj over Ki times this, but this is nice. This, as you can see, tells me Rj, so that's Kj over, all right? You with it? You can see it happening, right? Yeah, so I've got Rj. Now, here's the nice thing. Kj over Ki depends only on T, and T is given. Doesn't matter, doesn't care what the pressure is. So I know all the Kj's over Ki's, I know Rj. So look at my position now. After fooling around here, I know all the Ri's. All known. The Ri's are YIV over ZIF. So I know all the products YIV. YIV equals RI times ZI times F. So at this point I have all those products. Now I sum them. So V turns out to be the sum of RI, ZI, F. I now have V. I take V and divide the known YIV by V, and I now have all the YIs. So I'm now in the following position. I have all of the YIs at this point. I have V at this point. What do I need? Well, if I've got V, I've got L. So I have all the YIs. I've got V, therefore L. I'd like to have the XI, so how do they go? YI over KI equals XI. Now, I'm going to write this as KIP times P. KIP depends only on T, so these guys are all known. These guys are all known. So P times the summation of YI over KIP equals 1. I now have P. Yeah? So once I get P, I've got T and P. So I got T and P, and therefore the KIs, and therefore I get all the XIs, and I got everybody, I'm done. Okay? Looks pretty easy, right? Do this in a heartbeat, right? Good. Okay, that's problem 1 solved. So the question then becomes,
Do you have a question about?
huh?
Do you have a question?
Oh,
Can you explain what the index J is?
no, but you can talk louder and then I'll try it.
Can you explain what the index J is referring to and what the index
J is referring to a specific component whose recovery I know. Ri refers to all of the components I equal 1 to C. Okay? Including J, but I know J. My plan is to go try and calculate the recoveries of everybody else for all the I's. Which I did. And then take those Ri's, know that I've now got YIV for all the I's. Observe that if I got YIV, I've got V. And then to go and calculate P, I'm just going to write YI over KIX. I'm going to put a P here and a P here. Going to notice that KIP depends only on T, which I know. The YIs I now know. I'm going to sum this so the X's disappear. Got an equation for P. Okay? Yeah?
So the YIV over V, what is the V over V? What's the difference between the two V's? Are they the same V?
Absolutely.
Okay. So what does that help you say?
Look, I'll give you a chance to tell me.
Okay, the YI.
Huh? That's YI, that's right. YIV over V is YI. No doubt about it. But what's nice is, I know that